Hello all, good evening. Hope you are all doing good. Welcome to my YouTube channel all about VLSI. I hope my voice is audible and my screen is visible, right? So we'll start our session. So in previous session we have discussed about the arithmetic operations and complements in binary number systems, right? So in this session we will start with the number representations in binary. So how we can represent the numbers, binary numbers. Okay, so the topic name is number representations. So there are three type of number representations for positive and negative numbers in binary. So first type of representation is sign magnitude representation. Sign magnitude representation. So positive numbers and negative numbers in binary can be represented in three ways. One is sign magnitude representation, and another is ones complement representation. Ones complement representation, and followed by two's complement representation. Followed by two's complement representation. So we have three type of representation for representing our positive and negative numbers. One is ones complement representation, two's complement representation, and finally sign magnitude representation. So these are the type of representations for representing positive and negative numbers. Okay. So first let's start with the discussion of sign magnitude representation. What is meant by this? Sign magnitude representation. Sign magnitude representation. What is this sign magnitude representation? So in this case of sign magnitude representation, positive numbers, let's see how to represent these positive numbers. Okay, so in case of sign magnitude representation, in the case of positive numbers, MSB bit, for in the case of positive numbers, the MSB bit is 0. Okay, so for positive numbers the MSB bit is 0, whereas for negative numbers the MSB bit is 1. Okay, so the positive numbers are represented with MSB bit as 0, and negative numbers are represented with MSB bit as 1. Okay, so in case of sign magnitude representation, for positive numbers MSB bit is kept 0, while for in case of negative numbers the MSB bit is equal to 1. Okay, so this is the case of sign magnitude representation. Now let's see an example for the sign magnitude representation. For example, if we want to represent plus 5 in our sign magnitude representation, how to represent this plus 5? So the sign magnitude, the term itself indicates it has sign as well as magnitude. It has sign as well as magnitude in its sign as well as magnitude. Okay, so this sign is MSB bit, and remaining bits represent the magnitude. These are the remaining bits. These are the remaining bits. So now how to represent this plus sign? Plus sign is represented by 0. If MSB is 0, it is a plus sign. Now how to represent the magnitude 5? Which is nothing but the binary representation of 5 is nothing but 1, 0, 1. So this is plus 5 in sign magnitude representation. So this is plus 5 in sign magnitude representation. This is how we are going to represent plus 5 in sign magnitude representation. Now similarly, how to represent minus 5 in sign magnitude representation? Minus 5. So how to represent this minus 5? So for representing this minus symbol, what we will do in MSB, we will keep 1 followed by the magnitude. Magnitude of 5 is 1, 0, 1. So this is the representation of minus 5 in sign magnitude form. Okay, so in case of sign magnitude form, the MS for the positive numbers, the MSB is plus. For the positive numbers, the MSB is 0. followed by the magnitude. Okay, for plus 5 it is 0 1 0 1, and for minus 5 it is 1 followed by 1 0 1. So this is how you are going to represent positive numbers and negative numbers in case of sign magnitude representation. Now if you want to represent let's say plus 2, how you are going to represent it? So plus is indicated by MSB 0. So 0 indicates it's a positive number followed by the magnitude, which is 0 1 0. This is plus 2. And if you want to represent minus 2, then what happens? Then we will write 1 followed by 0 1 0. So this is minus 2. So this is the sign magnitude representation of plus 2 and minus 2. Likewise, in case of sign magnitude representation, we have two representations. We have two representations for 0. Okay. So likewise, all the other numbers in sign magnitude representation, for 0 also we have two representations. What are those two representations we have? Plus 0 and minus 0. But is it valid? Is there any number like plus 0 and minus 0? We have plus 2 or minus 2 or plus 3 or minus 3 or plus infinity, plus 100 or minus 100. But do we have plus 0 or minus 0? No, right? But in case of sign magnitude representation, we can have two representations for plus 0 and minus 0. For plus 0, what you can write? 0 followed by all zeros. And for minus 0, you can write 1 followed by all zeros. So like this, you have two representations for plus 0 and minus 0. But normally speaking, it's not possible, right, to have two representations for zeros. So this is the disadvantage of sign magnitude representation. Sign magnitude representation. So in case of sign magnitude representation, you have two representations for 0. That is plus 0 and minus 0. You can represent 0 in two forms, plus 0 and minus 0. But it is not valid. So this is the disadvantage of sign magnitude representation. I hope this is clear, right? Now, so to overcome this, we are going to discuss about ones complement representation. So before that, one more small point. So in sign magnitude representation, so in case of, I will write it here, one more small point. In case of sign magnitude representation, a n-bit binary representation can be used to represent decimal numbers in the range of minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1. Okay, so this is the range of numbers range of decimal numbers you can represent using this n-bit binary representation. For example, if you have a 3-bit binary representation, let's say n is equal to 3 bits. Okay, so what is the range of decimal numbers you can represent using this sign magnitude representation? Substitute in this formula: minus 2 power 3 minus 1 minus 1 to 2 power 3 minus 1 minus 1. That is minus 2 power 3 minus 1 is 2. That is 2 power 2, 4. 4 minus 1, sorry, 2 power 3 is 8, right? So 8 minus 1, 7. So 7 2. So if you substitute here 2 power n minus 1. So we have 3, right? 2 power 3, 8 minus 1. This is, sorry, 2 square 4, 4 minus 1 3. So you can represent it from minus 3 to here 2 power 3 minus 1, which is 2 square 4, minus 1 is 3, minus 3 to plus 3. So what are all the what is the range for this is minus 2 power n minus 1 minus 1 to plus 2 power n minus 1, where n is the number of bits. Okay, so for example, if n is equal to 8, okay, if n is equal to 8, then for using 8 bits, what you can do, how many decimal numbers you can represent? Minus 2 power 8 minus 1 minus 1 to 2 power 8 minus 1 minus 1. That is 2 power 7 minus 1. That is minus 127 to plus 127 is the range you can represent with the help of 8 bits. Okay, in sign magnitude representation, with the help of 8 bits, you can represent the decimal numbers from minus 127 to plus 127. Okay, yeah. Next comes the ones complement representation. Ones complement representation. So in the case of ones complement representation, in case of sign magnitude representation, we have seen that MSB is 0 for positive numbers and MSB is 1 for negative numbers. Here also, the MSB is 0 for positive numbers, MSB is 0 for positive numbers, and MSB is 1 for negative numbers. Okay, MSB is 0 for positive numbers and MSB is 1 for negative numbers. In the case of ones complement form also, MSB is 0 for positive numbers and MSB is equal to 1 for negative numbers. So in ones complement representation, the positive numbers remains unchanged. Okay, so here the positive numbers remains unchanged. Remember this point, remains unchanged. So the positive numbers, we are not going to touch them. They are not changed or not altered. Okay, so the positive numbers remains unchanged. Whereas to represent the negative numbers, in ones complement form, we are going to apply ones complement on them. We are going to apply ones complement. That's it. Is it clear? So in case of ones complement representation, to represent positive numbers, we are not going to change anything. Okay, we are not going to alter them. We are going to write them as it is. Whereas in case of negative numbers, we are going to apply ones complement on them. Okay, this is what we are going to do. For example, if we want to represent, let's say 5. So if we want to represent 5, how to represent it? So we will represent it by using sign bit followed by 1 0 1. Okay, this is 5. Now if you want to represent minus 5, then what we should do, we will apply ones complement on this particular binary number. Then it will be equal to 1 0 1 0. So this is the representation of minus 5 in ones complement representation, and this is a representation of plus 5 in ones complement representation. So to represent a negative number in ones complement form, first we will write the positive number in binary form and we will find the ones complement of that binary form. Okay, so how to find the ones complement of how to write the negative number in ones complement form? First we will write the binary number. Okay, so first we will write the positive number, binary form of that positive number, and then we will apply the ones complement on that particular binary number. So that's how we are going to write the write the negative number in terms of ones complement representation. Okay, now, so what is the range of numbers we can represent using this ones complement representation? So I'll write it here. Range of numbers which can be represented using one's complement form. So the range is equal to, so what is the range? Minus 2 power n minus 1 minus 1 2 plus 2 power n minus 1 minus 1. Same as sign magnitude representation. Okay. What is the range here? Minus 2 power minus 2 power n minus 1 minus 1 2 plus 2 power n minus 1 minus 1. So this is a range of numbers you can represent in the case of one's complement representation. Okay. I hope this is clear. Right? Now let's see one more type of representation, which is 2's complement representation. What is it? Which is 2's complement representation. 2's complement representation. How to represent negative numbers in this 2's complement representation? First, let's see the positive number. So the positive number, let's say plus 6, it is written as 0, 1, 1, 0. So to represent minus 6 in 2's complement representation, we will apply 2's complement on this particular number so that the number will be represented in 2's complement representation. So the minus 6 will be represented in 2's complement representation. So how to apply 2's complement on this? First we will apply 1's complement, 1, 0, 0, 1, and we will add 1. So it will be equal to 1, 1, 0, 1, 1, 0, 1, 0, 1, 0. So this is the 2's complement representation of the negative number minus 6. So this is how we are going to represent minus 6 in 2's complement form. So what we are going to do? We are going to write the positive number, write the positive sign number, and we are going to find the 1's complement of that number, and then we are going to add 1 to that number so that it can be represented in 2's complement form. So this is how we are going to represent a number, a negative number in 2's complement form. Okay. So yeah, so that's how we are going to represent negative numbers and positive numbers in case of sign magnitude representation, as well as 1's complement representation and 2's complement representation. I hope this is clear, right? Now let's see addition using 1's complement. Okay. Now let's see how to add this topic, addition using 1's complement. How to add two numbers using 1's complement representation. Okay. So let's say if we have two numbers 5 plus 2, right? So if we have two numbers, let's say if we have two numbers 4 plus 2, okay, so the result will be 6, we know. Okay, this is what we have, 4 plus 2. So how to add these two numbers using 1's complement representation? So to add these two numbers in 1's complement representation, we have plus 4 and plus 2. So to represent these numbers in 1's complement form, now only we have learned how to represent this plus 4 and plus 2 in 1's complement form. So in case of plus 4 and plus 2, that is the positive numbers, in case of 1's complement representation, they are written as it is. There is no change in the representation. That is, they are written 0, 1, 0, 0. There is no change in the case of positive numbers in case of 1's complement representation that we have seen now only. Okay, 0, 1, 0. So this is how we are going to represent these two numbers plus 4 and plus 2. And we are simply going to add them. 0, 1, 0, 0, 0, 0, 1, 0. What is the output? 0, 0 plus 1, 1, 1, 0. So this is our final output. So this is how we are going to add two numbers in case of 1's complement number. Now, if we have this case 4 plus minus 2. So we have to add these two numbers 4 and minus 2. So what is the output we have? That is equal to 2. Okay. Now how to write this? So plus 4 is written as it is. Since it is a positive number, first what we should do? We should represent the numbers in 1's complement form. So how to represent plus 4 in 1's complement form? It is written as it is. Since it is a positive number, there is no change in the 1's complement representation. So it is written as it is. So it is MSB bit is 0 followed by 1, 0, 0. Next, how to write minus 2 in 1's complement form? Now only we have seen. So to represent minus 2 in 1's complement form, first we should write plus 2. So what is this plus 2? Which is nothing but 0, 1, 0, 0, 1, 0. Now for representing minus 2, what we'll do? In 1's complement, we will complement this particular number. Then it will become 1, 1, 0, 1. So this is the 1's complement representation of the number minus 2. Now we are going to add this. So minus 2 is nothing but 1101, 1101. Now we are going to add these two numbers. What we will get? 1, 0, 1101, 1, 1101. So here we are getting a carry. Okay. So after performing the addition, we are getting a carry. So this carry will be again added. So if we get any carry, it indicates it is a positive number. So we will again add this carry with our result. So final result will be 110 carry 1 100. So the final answer is 0010. And we should check for the MSB also. This MSB is 0, which indicates the final answer is a positive number. So we can end the process here. So finally the answer is 0010. So this is how we are going to add two numbers using 1's complement representation. Okay. Now how to add? Now let's consider this scenario: minus 4 plus 2. Okay, we are talking about addition using 1's complement. Now how to add this? First we should represent the numbers in 1's complement representation. So how to represent minus 4 in 1's complement representation? First we should represent plus 4 in 1's complement representation, that is 0, 1, 0, 0. So minus 4 is nothing but 1's complement of plus 4, that is 1, 0, 1, 1. So minus 4 is nothing but 1, 0, 1, 1. Now we will add this 1, 0, 1, 1 with 2. So finally it will become 1, 0, 1, 1 plus what is representation of 2? It is plus 2, right? So we are not going to alter anything. It is same as it is. It is written in its original form, which is 2 is nothing but 0, 0, 1, 0. Okay. Now we are going to add these two numbers, which is nothing but 1, 1, 1 is 0, carries 1, 1 and 1. So this is the final answer. But in this final answer, you can observe we are getting MSB as 1. So here in the final answer, if the MSB is equal to 1, then it indicates that it is a negative number and it is in 1's complement form. So if in the final answer, if the MSB is 1, and so if in the final answer, if the MSB is 1, then it indicates it is a negative number and it is in 1's complement form. So to get the original number, what we will do, we should perform 1's complement again on this final answer. Okay. So to get the original number, we should perform 1's complement on our result again. So what is the 1's complement of 1101? Which is nothing but 0, 0, 1, 0. This is our final answer. This is our final answer, which is nothing but minus 2. Okay. Which is nothing but minus 2. Okay. Do remember the sign is very important. Minus 2. It is not plus 2. It is minus 2 because in our previous final answer, the MSB was 1, which indicates it is a negative number. Okay. So that's why it is minus 2. Not minus 1. It's a minus 2. Okay. Yeah. Next. So this is how we are going to add two numbers using 1's complement representation. Okay. Now let's see how to subtract using 1's complement representation. Let's say if we have 4 minus 2, we know the result is 2. Okay. Now first step is we should represent the numbers in 1's complement form. So plus 4 is represented as it is. We have seen that, right? So in 1's complement form, plus 4 positive numbers are represented as it is. So plus 4 is nothing but 0, 1, 0, 0. And minus 2, how to represent minus 2 in one's complement form? So we should represent plus 2 first, which is nothing but 0, 0, 1, 0. And for representing minus 2, we should complement this plus 2, which is nothing but 1, 0, sorry, 1, 1, 0, 1, 1, 1, 0, 1. Now we will add this 1, 1, 0, 1 and this 0, 1, 0, 0. So by adding what we will have 0, 1, 0, 0 and 1, 1, 0, 1, 1, 1, 0, 1. Right? So what is our answer? 1, 0, 1, 1 is 0, 1, 1, 1 is 0, 1. We will have a carry 1. So if we have a carry 1, what we should do? We should again add this final result with this carry 1. So if we add this final result with carry 1, then what will be our final result? 1, 1, 0, 1, 1, 0, 0. Okay. So here the MSB is 0. It means it is a positive number. Then there is no need to complement the result. Okay. So if the MSB is 1, then it indicates it is a negative number and we should complement the number and we should keep the negative sign with that. Okay. Since the MSB is 0 here, it indicates it is a positive number. So what is our final answer? It is equal to plus 2. So this is how we are going to subtract two numbers using one's complement. Next, let's say if we have 2 minus 4. If we have 2 minus 4, then how to do? 2 is nothing but 0, 0, 1, 0 and minus 4, which is nothing but, first we should write the representation of 4, 0, 1, 0, 0 and minus 4 is nothing but complement of plus 4, which is nothing but 1, 0, 1, 1. Okay, 1, 0, 1, 1. Next we are going to add this 0, 0, 1, 0 and 1, 0, 1, 1. So we will get 0, 0, 1, 0 plus 1, 0, 1, 1, 0, 1, 1. So what will be our final answer? 1, 1, 1, 0, 1, 1, 1. So in the MSB, if you observe, MSB is equal to 1. MSB is equal to 1. So it indicates it is a negative number. So if we want the answer, the original number, we should again complement this final answer. So the final answer will be 0, 0, 1, 0, which is nothing but minus 2. We should keep minus symbol since the MSB was 1. So the final answer is minus 2. So this is how we are going to subtract two numbers using one's complement form. Now let's see how to perform subtraction using 2's complement form. Okay. Let's say if we have same number 4 minus 2 we will consider, which is nothing but 2. Okay. How to represent 4 in 2's complement form? 4 is not changed. Since it is a positive number, in 2's complement form there is no change in positive numbers that we have seen in our previous slides only, right? So for positive numbers there is no change in 1's complement and 2's complement. So it is written as it is 0, 1, 0, 0. Next, how to represent minus 2 in 2's complement form? First we should write plus 2, which is nothing but 0, 0, 1, 0. And if we perform 1's complement, what we will get? 1, 1, 0, 1. Plus 1, we will get 2's complement. 1, 1, 0, 1, 1, 1, 1. This is 2's complement form of minus 2. We are representing minus 2 in 2's complement form. Okay. Now we are going to add this 111 with our 0, 1, 0, 0. So 111 we are going to add with 0, 1, 0, 0. 0, 1, 0, 0. So what will be our final answer? 0, 1, 1, 1, 0, 1, 1, 1, 0, 1. We are getting a carry. So if we get a carry, we are going to add it again. So plus 1. We'll get 1, 1, 0, 0. This is our final answer. Okay, so this is how we are going to do. Wait a minute, let me check. 1101 1101. So 2 is 0010, 1110, 1110, and 0100. Sorry, here it is 0100. So we get 0 1101 1101. Okay, 1 minute, I will write it again. So we are doing 2 minus 4, right? Sorry, we are doing 4 minus 2. 4 minus 4 is nothing but 0 100, and 2 is nothing but, sorry, minus 2 is nothing but so how to represent minus 2 in 2's complement form? First we should represent 2, which is nothing but 0 1 0, sorry, 0 0 1 0, and 1's complement is nothing but 1 1 0 1, plus 1 we get 1 1 0 1 1 1 1 triple 1 0. Okay, this triple 1 0 we are going to add it here, triple 1 0. Then what will be the answer? 0 1 1 1 0 1 1 1 0 1. Okay, next we are getting a carry, here. Okay, so that carry we are carry forwarding here. Okay, so here we are representing 2, that is 0 0 1 0. Okay, 0 0 1 0, which is nothing but 1 1 0 1, and we are adding 1, we will get 1 1 0 1 1 1 1 triple 1 0. So this we are adding with 4, 0 1 00 triple 1 0. So what is our answer? 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 0, carries 1, 1 plus 1 is 0, carries 1, and that carry we will add it further to get our final answer. Okay, so what we are doing here, so if the MSB is 0, so if the carry is generated, we will add it to the LSB position. So here if we add it, then we will have 1 1 0 0. So this is the final answer we are getting. So if the MSB is 0, then the answer is in positive and true form, and if MSB is 1, then the answer is in negative form. Okay, so this is how we are going to subtract two numbers using 2's complement form. I hope this is clear, right? So if you're having any doubt, you can ask me. Any doubts or queries? Yeah. Then we will wrap our session here. We will discuss further in our next session. Okay. Yeah. So that's all for this session.